Hi everybody, I'm going to speak about the determination of activity coefficient for strong electrolytes. So in the last three videos I have given the concept about Arrhenius theory, Debye-Huckel's theory, and then I came up to activity coefficient. Okay, so now I'm going to tell about the determination of activity coefficient for strong electrolyte. So Debye-Huckel theory is based on the three assumptions that the solution is dielectric continuum of dielectric constant, and this is represented as psi r. Second one is the ions are hard spheres of diameter A and the concentration is rho, that is dilute. So what is dielectric constant? So this is nothing but it is represented as kappa K and it is expressed as C by C naught, where C is the value of capacitance of a capacitor filled with given dielectric and C naught is the capacitance in vacuum. So dielectric constant is C by C naught. Dielectric continuum is the dipole density that defines the macroscopic polarization. Okay, so suppose we have a molecule and it is surrounded by water molecules. Okay, so this water molecule is mentioned as dielectric continuum. So the central ion can be neutral or it can be a charged particle. So the water molecules surrounding it is called as dielectric continuum. So I have represented this one in the diagram part of it. You can just look into it. So rho is the charge density, dV is the volume element, R is the distance from the central ion, psi r is the mean electrostatic potential, and the Poisson equation is given as lambda square psi r is equal to minus of 4 pi rho by epsilon r, where del square is the Laplacian operator. In terms of spherical polar coordinates, the Poisson equation is given as del square psi r is equal to 1 by r square dr, r square d psi r by dr. This is nothing but what we gave the Poisson equation, previous one, minus of 4 pi rho by epsilon r. So charge density in volume element is equal to excess charge in the volume element. And this is equal to the sum of each ion density in Ni times the ZIE on the ion. ZIE is nothing but the charge. So rho is equal to sigma I Ni ZIE. Ni is the average number of I ions per unit volume. So for the central ion, if it is a positive ion, so R naught limit, integral of limit R naught to infinity 4 pi square rho dr is equal to minus of Ze. So where Ze is the charge of the central ion, R naught is the distance of closest approach between the central ion and the surrounding ion. If we have the central ion as positive ion, the surrounding ions will be negative ions. Okay. The ion density Ni in equation 3 is related to electrical potential by Boltzmann expression. So what is the equation 3? Rho is equal to sigma I Ni ZIE. Okay. So Ni is equal to Ni naught exponential of minus of ZIE psi r by kT. So this is equation 5, where Ni naught is the average bulk density for ith ion at the point epsilon r is equal to 0. So this is the first Debye-Huckel approximation of the first three assumptions This is the first one. So the charge density is a function of R of the volume element in a given is given by rho R is equal to sigma Ni naught Zi exponential of minus of Zi psi R by kT. So this is the equation 6, and the kinetic energy of the ions is much greater than the electrostatic energy. So this is the second d by Huckel approximation justified when the solution is dilute. So equation 6 in terms of Taylor series I have given. Okay, 1 by r square is into d by dr, r square d psi r by dr is equal to k square psi r. Okay, so dielectric constant kappa k. This is Poisson-Boltzmann equation where k is kappa, dielectric constant. K square is equal to 4 pi e square epsilon kt into sigma I Ni naught Zi square. Okay, so this is equation 8. So here I have shown the diagram in which you have the positive charge in the center. So with a charge of Zi e, and a is the distance of the closest approach. Okay, and 1 by kappa is the radius of the ion atmosphere. So this is the sphere of ion atmosphere. The electroneutrality condition of the solution is used. Okay, so sigma I Ni naught Zi is equal to 0. The value k square is proportional to the ionic strength and becomes 0 when the solution reaches infinite dilution, which was our last assumption. So if we substitute yr is equal to r psi r, equation 7 reduces to d square yr by d r square is equal to kappa square yr. This is equation 10, and the differential equation has the solution as yr is equal to a exponential of kr plus b exponential of kr. The next one is psi r is equal to a exponential of minus of kr by r plus b exponential of kr by r. So a and b are integration constants. So when psi r approaches 0 and r approaches infinity, then b is equal to 0. So the following equation is derived from equation 6. Okay, so rho r is equal to minus of a k square epsilon r by pi 4 pi into exponential of minus of kr by r. Substituting rho r from equation 12 into equation 4. Okay, so we get the expression as a k square epsilon r integral of r naught to infinity r exponential of minus of kr dr is equal to Ze. So integration of this 13th equation gives equation 14, a is equal to Ze exponential of k r naught by epsilon r 1 plus kr. So the psi r electrical potential around the central ion is psi r is equal to Zi into exponential of minus of k r minus a by epsilon r 1 plus kr. So this is d by Huckel equation, and the solution is dilute. The electrical potential is the sum of the contributions from the central ions and the surrounding ion, that is our ionic atmosphere. So psi r is equal to psi dash r, that is of the central ion, and psi n r, that is of the surrounding ions, because you will have n number of ions. Psi r is the same dielectric continuum is psi dash r is equal to Zje by psi r, epsilon r. Hence psi to the power of n r is equal to zje by epsilon r into exponential of minus k r minus a by 1 plus ka minus 1. So the mean coefficient, activity coefficient, gamma for positive and negatively charged ion is given by ln of gamma plus minus is equal to minus of z plus z minus e square by 2 epsilon r kt into k by 1 plus ka. Finally, the mean ionic activity coefficient in terms of ionic strength is given by log of, if we convert ln to log, then log of gamma plus minus is equal to minus of 0.512 z plus z minus I to the power of half. In denominator you have 1 plus 0.329 into 10 power 8 a I to the power of half, where epsilon is 78.3 at 298 Kelvin. A is the length in centimeter. Thank you. I hope the video was useful. Okay, so this is the concept of determination of activity coefficient based on the three assumptions and based on Poisson-Boltzmann equation. So I hope the derivation was clear. The details you can look into the description box for the elaborate derivation concept. Thank you.